In this video, I'm going to share with you the top 5 algebra skills that are needed to be successful with the ACT. And I'm also going to show you some tricks that are going to help speed up things and make sure you're not caught out by some of the slightly trickier questions. So let's start with working with weird roots. So when something like this comes up, students tend to go to pieces. So you've got the square root of x cubed multiplied by the 5th root of x to the power 4. So there's loads of different rules of algebra going in here. And when you understand this question, you're going to be able to deal with square roots very confidently. So let's start by breaking it down. So we're going to look at this term first and then look at this term. So start with this term and let's do it over here. So this is, of course, equivalent. So we've got a cubed here. Cubed means 3. So this is equivalent to 3 square roots of x's. And for this problem, we've got two rules in action. We're going to look at one rule and then look at the next rule. So the first rule is that the square root of x is exactly the same as x to the power of a half. So whenever you see a square root of x, you can always replace it with x to the power of a half. And when you start using this, you can use all of your index rules that make life so much easier. So exactly in the same way, we're going to replace all of these square roots of x's with x to the power of a half. So we get 3x to the powers of a half. So each one of these replaced with x to the power of a half. Now we can use our index rules. So we know that when you multiply powers, you simply add them. So you can take this half plus this half plus this half, and we get 3 over 2. That's simply adding fractions. There is a shortcut, which is rule 2 here. So where you have something in this form, you've got the bth root. So this could be 2 if it was a square root, 3, 4, 5 for all the other roots and so on. And we've got x raised to the power a. So whatever power x is raised to goes on the top of the fraction, and our root goes on the bottom of the fraction. So here we can see that we've got the power 3, so 3 goes on the top, and then we don't have a 2 written here, but 2 is implied because it's a square root. Whatever's there goes on to the bottom, and so we could jump straight to that. And that's what we're going to do here. So we can jump straight to this using our rule. So the 4 goes on the top and the 5 goes on the bottom. So this is equivalent to this as a fractional power. So we can then replace this with what we've got down here, and then this can be replaced with what we've got here. So this expression is equivalent to this with fractional powers. And we can use exactly the same rule as we used down here and simply add these two fractions. You'll have to find a common denominator before you can add them. And when you do that, you'll get x to the power of 23 over 10. And then we can apply this rule backwards. So the bottom number is going to go onto the root, and the top number is going to go onto the power. And so that can be written in that form. So we've been able to do this forward and backwards. So take a second to go through that again, and you'll see some really important rules of algebra. And this definitely will come up. This principle I've seen many, many, many times in the ACT. So let's look at the next one, which is nasty negative powers. Whenever you have negative powers, they can be a real pain. But the good news is you can transform any negative power into a positive power. So we've got x to the power negative 1/2, and this is equivalent to a different fraction. And so here's the rule, and you should be able to spot a pattern by going through this. So x to the power 1 is 1 over x to the power minus 2 is 1 over x squared, and x to the power minus 3 is 1 over x cubed. If you haven't spotted the pattern yet, it's actually the negative disappears when you do 1 over, and then whatever the power here becomes the power on the bottom. So like in this one, we've got minus 2, so we get rid of the minus by putting the x on the bottom of a fraction, and then so we've got a 2 here, you get a 2 here. And so we can do exactly the same thing here. So we're getting rid of the negative by putting it on the bottom, and the power is just copied across. But if you remember from the previous question, you should remember that anything to the power of a half just means square root. So you can replace that with 1 over the square root of x. And so whenever you have a negative power, remember you can just put it at the bottom of 1 over and it goes away. Moving on to number 3, which is rearranging logarithms. So some of the questions towards the end require you to rearrange logarithms. And there is a simple rule, which is if you have something log to the base a of x equals b, it can be written in an exponential form. So that means a number to a power. like this. So whatever your base is, you raise that to the power of the thing on the other side. So you're left with the x. So the base raised to the power of the thing on the other side. And so let's apply that here. So we've got log to the base 2 of x is equal to 10. So we just do the base to the power of the other side. So we get x equals the base to the power of the other side. And if you just put that into a calculator, or if you're familiar with binary, you probably could do that a lot quicker. You get x is 1024. And that's the final answer. So we've been able to quickly rearrange the logarithm by realizing you just take the power, you take the base rather, and you raise it to that power. Moving on to number 4, which is completing the square, which is a really useful technique in algebra and can be one of the questions. So the question could be something like, express this x squared plus 10x plus 28 in the form x plus a squared plus b. And there's 2 steps. So step 1 is you take whatever the middle number is. So I'm talking about this middle number here, whatever it is, and you half it, and that's your a. So we're up to here. So we've got a just by halving this number. So you see a is 5. So replace that. That's the only thing we've done. We replaced the a with 5, which is half of this number. Then step 2 is to find b. So we've got a b here, and we need to have plus 28 on the end. And you know when you multiply this out, that you're going to end up with 5 times 5, which is going to give you a plus 25. And you don't want plus 25. You want plus 28. So when this is multiplied out, the constant term is going to be 25, which is no use. You want 28. How do you turn 25 into 28? You have to add 3. And you can multiply that back out to check that it works. You're just looking at this term at the end, squaring it, and then just sort of figuring out what number you need to add on to get back to that 28. And when you multiply this out, you will actually get that straight back. So you can always write something like this in this alternative form. So completing the square is a really important skill for the ACT. Last one is simplification by factorisation. So we've got this expression here, which I'm going to copy down to here. And we want to find this in the simplest form. And so I've got these 2 arrows, which are indicating that we're going to do this problem in 2 halves. So obviously, x minus 4 cubed is just that written out 3 times. So we've got x minus 4 times x minus 4 times x minus 4, which is what our cubed is telling us. On the bottom, we need to use our factorisation techniques. So we need to look for 2 numbers that add to give minus 6 and multiply to give plus 8. If you're not familiar with this, you need to revise your factorising. So we just go through all the possibilities, numbers that add to give minus 6, you go through all those, and then all your numbers that multiply to give plus 8. And when you do that, you work out that minus 4 minus 2, you add those 2, minus 4 plus minus 2 does add to give minus 6, and minus 4 times minus 2 does in fact give you plus 8, because minus times minus is plus. And if you were to multiply that back out, you will get back to this. So we know we can replace these 2 with those factorized forms. So I've just substituted this in the top here and substituted this in the bottom here. We've then got some things that are repeated. So some things are appearing on the top of the fraction and the bottom. And so we can just make those disappear. So this term here, this x minus 4 is just going to cancel with this, because you're dividing one thing by the other. 5 divided by 5 is 1. So it just disappears. Whenever you're dividing something by itself, it always becomes 1. So we can just make those disappear. And so it simplifies to this. And of course, these 2 terms multiplied together is the same as squared. So it will probably take you a while to pause the video, go through each example clearly. There's a fully worked solution with my explanation, so you may need to see it a few times for it to sink in. Hopefully it's been very helpful to you. If you can do all these 5 skills, your ACT grade should go up significantly. And finally, thank you for watching.